Hi, it's Elif Sultan Yelmenoglu. I'm first-year mechanical engineering student at Bilkent University. Today, I'll introduce my phys101 experiment. In this experiment, we are putting a mountain slab of friction to the test. My goal is to determine the friction coefficients for paper, wood, and plastic surfaces, and specifically to see if friction really is independent of velocity and normal force, as classic physics claims.
To start the experiment, let's look at the equipment list. First, we need a sliding block which has a definite weight, and a dynamometer to measure the force, and wooden, paper, and plastic surfaces. Extra weight to increase the normal force, and we need a definite long rod to measure the velocity, and stopwatch and metronome to simulate the constant velocity. We are measuring the masses of the different blocks. First, we are measuring the static friction force at different surfaces. After that, we measured the kinetic friction and we calculated kinetic and maximum static friction coefficients. And now, let's try to simulate different constant velocity amounts and try to see independence of velocity. As we can see from the graph, the independence of the velocity of kinetic friction is verified. Lastly, we are adding an extra weight and try to understand whether the friction force is independent of the normal force or not by increasing the normal force.
In conclusion, while we proved that speed doesn't change friction, we observed that increasing the normal force significantly altered the coefficient. This deviation suggests that under higher pressure, the soft surface is deformed, increasing the real contact area. It shows that Hamilton's laws are ideal approximations that may fail in the real-world conditions. We also observed the instrumental errors depending on these results.